Okay, sound. That'll do. Okay, so this is going to be a little video about getting your robot to move forwards, backwards, and side to side. So left and right. If you can do that, and you can read the input off the joystick, which we've already done if you're in Year 10, then you're going to be able to steer this thing. So we're going to look at how to do that. So what have we got? You have something that is connected like this. So you've got your dual H bridge, and I say dual because it says H bridge here, but it's actually got two of them in here. That's why you can drive two motors. You've got power going into your H bridge. We're using the onboard 5-volt regulator to feed 5 volts into our Arduino so that we can power our Arduino. We've got 5 volts coming out of the Arduino into this rail and ground over here. And we've got our grounds connected. So when you hook the positive lead of the power supply up to this cable and the negative lead of the power supply up to this cable, this should be powered and that should power your Arduino. Now, a real quick refresher, how do H bridges work? Well, you've got, and I'm missing a picture. Here we are. Okay, that'll do. So here's a really simple diagram of your robot, right? So you've got your base and you've got two driving wheels. To control these two wheels, which are driven by these two motors, you have these two motor drivers. And these H bridges work because if you close the switches I and 1 and you turn E and A on, or you turn it to high, then current is going to flow from the positive through in 1, this way through the motor, back through this in 1 switch, and down to ground. If you open in 1 and you close in 2, these switches, then current will flow from positive to negative the other way. So you can control whether your motors turn forwards or backwards. Now, what you're going to try to do today is to make both wheels turn forwards. Both wheels backwards, right turn, left turn. So how do we make a motor move? So let's say that we want to make motor A move. We'll call this one motor A, and we'll say that motor A is driven by like these set here, E and A in 1 and in 2. So motor A turns. What do we need? Well, we need E and A needs to be on, and then IN1 and IN2. Now one of these needs to be on and one of these needs to be off. And that will control the direction. So if we turn IN1 on and IN2 off, the motor will turn a certain direction. And if we reverse that, so if we turn IN1 off and IN2 on, the motor will turn another direction. So that's going to turn motor A. And then motor B is going to be the same thing, but with ENB, IN3, and IN4. So let's have a little look at what that code is going to look like. So, and let me just put this picture over here because this picture will be helpful to us. Whoop. Yep, great way to work a desktop. All right, so first thing, we need to declare our pins. And right now, what I'm looking at has 6 pins from my Arduino connected to my motor controller, and I've got them connected like this. Now there's a reason that I have them connected like this. It's so that we can do some speed controlling stuff later, so yours should be connected like this as well. So we need to tell the Arduino where all this stuff is. So to declare something, const int, and then give it a name. I'm going to call it ENA because that makes a lot of sense. And tell, semicolon, tell your Arduino which pin is plugged in, or which pin that is plugged into. IN1 is equal to 4. Beautiful, that's all the pins that I'm going to need for the moment. Now, are these inputs or outputs? So think about it. Are they receiving a signal? So is the Arduino receiving a signal, or are we sending a signal out? Well, if we think about these two H bridges, we need to send a signal to close these switches, and we need to send a signal to turn ENA on or off. So these are outputs, right? They are sending something out. So and I'm going to do that for all of my Okay, so we've got that done. Now, I'm going to create 4 chunks of code, if you want to think about it that way, for each of the things that I want to do. So I want to turn both wheels forward. I want to turn both wheels backwards. I want a right turn. I want a left turn. So let's go both motors forward. So to turn a motor at all, I'm going to need to do the following things. I'm going to need to go so that's going to turn ENA on. And I'm going to leave IN1 high. And I'm going to turn IN2 to low. So let's call this. Apologies for the interruption, guys. So let's call that motor A, because that's going to move motor A, right? Motor B, we basically need to do the same thing, right? Motor B, except now we've got ENB, IN3, and IN4. And what I'm trying to do here is I'm going to just try and run some code, and I'm going to figure out for these commands. So for motor A, if I set ENA to high, let's get a picture up. If I set ENA to high, and I set IN1 to high, and I set IN2 to low, which direction does my motor spin? So I would run this code, right? And I would observe, okay, so this motor over here, motor A, is that turning forwards? Okay, if it's turning forwards, great. This set of instructions makes it turn forwards. If it doesn't turn forwards, well then I need to reverse the direction of current through the motor. So if, ENA is on, IN1 is on, if that is resulting in the motor turning backwards with respect to my robot, well then I know that I need the current to flow the opposite direction through the motor. So I need IN1 to be off or low, and I need IN2 to be high or on, and then my motor should turn forwards. So you're going to write code that looks like this, and you're going to run it and watch what your robot does. And so that you can watch it and actually get a decent idea of what's going on, we're going to go and just put a delay in there. So a delay of 1.5 seconds. And so when you plug this in and you run it, you should be able to go, okay, motor A, what's it doing? Motor B, what's it doing? Are they both turning forwards? If so, great. These bits of code make my motors turn forwards. If not, is motor A turning backwards? I got to swap these around. Is motor B turning backwards? Then I have to swap these around. Once you know that, it should then be really easy to write the rest of your code. So what I would want you to do after you've tested it is go, okay, cool. Both motors backwards. And below here, I would put the code for both of my motors going backwards, right? Both motors backwards, code below here. Right turn, code below here. And right, so you would have the code that makes both motors turn backwards. You would stick that under here. Then you would figure out, okay, so how am I going to get a right turn to work? Well, we're using what's called differential steering. And the way that works is if I want to turn right, this motor can stay still, and my left motor can move forwards, and that'll mean my robot will move in an arc. Or, if I like, I can make this motor turn backwards and this motor turn forwards, and it'll get a lot closer to pivoting on the spot, if that's what you want to do with it. So, do that, come up with some code that makes your robot go forwards for half a second, backwards for half a second, right for half a second, and left for half a second. Once you've got those nailed down, it's actually really simple to combine that with your joystick reading, so the read from that input, and to control that robot. So that's what you're going to do.